Welcome back for another deep dive. Today we're going to be going back to basics with electricity and circuits.
So fun.
Yeah, we've got this really cool chapter from a science textbook.
Okay.
And it's kind of geared towards like a younger audience.
All right.
But you know what that means. Really clear explanations and fun activities.
Awesome.
Perfect for a deep dive, right?
Yeah, sometimes going back to the fundamentals is really good.
Absolutely.
Even for people who think they already know this stuff.
It's like revisiting the foundation of a house.
Right.
We might live in it every day, but do we really get like how it all works?
Right.
And speaking of how things work, this textbook has some seriously cool DIY activities
Oh, cool.
that show us how electricity actually does its thing.
Nice.
I'm going to give you a little teaser, though.
Okay.
By the end of this deep dive, you're going to discover a really surprising material
Okay.
that can actually conduct electricity.
Huh. I'm intrigued. I wonder if I can guess it.
Okay, let's see if you can figure it out along the way. Okay, so let's start with something we all use and see pretty much every day, a flashlight.
Okay.
So simple, but it really shows the basics of electricity.
Yeah.
And at the heart of our flashlight is the electric cell.
Right.
You can think of it as like the engine that powers it all.
Right. Every engine needs fuel, though.
That's true. That's true.
And for an electric cell, the fuel is like the chemical energy inside.
Yeah.
And so those chemicals they react to produce the electric current.
Okay.
And that's what makes the flashlight work.
Which is why batteries eventually die, right?
Exactly.
Because they're just a bunch of electric cells all packaged together.
Yeah, that's right.
Speaking of batteries, though, this textbook has a whole caution section
Oh,
emphasizing like only using electric cells for these activities,
okay.
not the electricity that's coming from like household wiring.
That makes sense.
Right. Good reminder for all of us.
Yeah, absolutely. Because even though it's just a simple battery,
Right.
it's still a powerful force.
It is.
Yeah. Gotta respect that power for safety, you know?
For sure. So true.
Yeah.
Okay, so let's shift gears a little bit from that power source to the light itself.
Yay.
The bulb.
The bulb.
We've all seen a light bulb, but have you ever actually stopped and thought
Yeah.
about what's happening inside that little glass casing?
Yeah. It's actually pretty amazing.
Yeah.
When you think about it.
Yeah.
Inside the bulb, there's this thin wire, and it's called a filament.
Oh.
And when the electricity goes through that filament, it heats up
Oh, wow.
to a really, really high temperature, and that's what makes it glow.
So that's what's creating the light.
Yes, exactly.
And even though all the bulbs in our house might look a little different,
Right.
they pretty much all work on this same idea.
Yeah, pretty much.
Okay, but I'm curious, why does the textbook warn us about touching those metal parts of the bulb?
Oh, that's a good question, and that actually brings us to our next topic,
Okay.
which is circuits.
Okay.
It's all about creating a safe path, a
Right.
controlled pathway for that electricity to flow. If you go touching those metal parts, you could mess that up,
Right.
and it could even be dangerous.
So it's like a safety thing too.
Yeah, definitely.
So how do we actually make a light bulb shine? How do we make that happen?
Wow.
The textbook has this really neat activity.
Oh, fun.
You get to experiment with like connecting wires to a bulb and an electric cell.
Okay.
But it turns out only certain arrangements actually make the bulb light up.
Why is that?
It's all about creating a complete circuit.
Ah,
So
okay.
you have a closed loop.
Right,
For that bulb to light up the electric current, needs a clear path to flow
right.
from the positive terminal of the electric cell all the way through those wires, through the bulb's filament, and then back to the negative terminal.
Okay.
So if there's any break in that loop at all, the light's not going to come on.
Exactly. It's like a road with a detour.
Okay.
If that path isn't continuous, the electricity can't reach its destination.
Ah, that makes sense.
The book actually suggests a clever little trick.
Okay, what is it?
You can use a pencil to trace the path of the circuit.
Oh, interesting.
And if you can trace a continuous line all the way from one terminal of the cell, through those wires, through the bulb, and back to the other terminal,
Then you've got a complete circuit.
then you've got it.
Okay, cool. So that's a good way to make sure you've got everything connected properly.
Yeah, for sure.
But what about those times where you think you have a complete circuit,
Yeah.
but the bulb's still not lighting up?
Mm.
Is it always just like a problem with the wiring?
Not necessarily.
Okay.
Sometimes the problem could be within the bulb itself. Remember that filament we were talking about?
Yeah.
If that filament breaks, even if your wiring is perfect, the circuit's broken.
Oh.
And the bulb won't light up.
So like a bridge collapsing,
Exactly.
even if the roads leading up to it are fine.
Right.
If that bridge is out, you're not getting across.
You're not going anywhere.
Makes sense.
Yeah, and understanding this idea of a complete circuit, it's really important for building anything electrical.
Which brings us to our next activity, building a homemade torch.
Ooh, fun.
I love that this textbook is so hands-on.
Yeah, it's great.
You get to actually build stuff.
It's one thing to just read about these concepts.
Yeah.
It's another to experience them firsthand.
Absolutely.
That's where the understanding really clicks.
So how do we make this homemade torch?
Okay, so you take a wire, wrap one end around the base of a light bulb, and then you touch the other end of that wire to the terminals of the electric cell.
Okay.
And when you make that connection, you complete the circuit, and the bulb lights up.
So simple, but so cool.
I know, right?
And if you pull the wire away?
You break the circuit, and the light goes off.
Oh.
So it's a simple demonstration, but it really shows how that complete circuit is key for the flow of electricity.
So we've got our power source, we've got our bulb, we've got our circuit. What about those wires themselves?
Yeah.
Do they have to be made of something specific?
That's a great question.
What if we tried something totally different? Like replacing a wire with a piece of string? Would that still work?
That's a really interesting question.
Yeah.
And it leads us to the whole world of conductors and insulators.
Okay.
So some materials, like those metal wires that we've been using, they let electricity flow through them easily.
Okay.
Those are our conductors.
The conductors.
But other materials, like string or rubber, they actually resist that flow of electricity.
Okay.
And we call those insulators.
Insulators.
So it's like conductors are the highways for electricity.
Yeah.
And the insulators are like roadblocks.
I like that.
Yeah.
Okay, so it's all about what the material is actually made of.
Right. Some materials are just naturally good at letting electricity flow through.
Right.
And others are good at resisting it.
Very cool.
Yeah.
So we're going to dive into this a little bit more later.
Yes, we are.
We'll be back after a quick break. Welcome back to our deep dive on electricity.
It's amazing how these simple ideas can be so fascinating, right?
Right. I'm really excited to keep exploring.
You too.
Okay, so we've already talked about electric cells and circuits and that difference between conductors and insulators.
Right, the basics.
But this textbook really challenges you to use what you've learned.
Oh, okay.
It's got this activity where it gives you a situation where a bulb just won't light up,
Okay.
even though you think you have a complete circuit.
Interesting. So what's the catch?
Well, this is where things get kind of tricky.
Okay.
It all comes down to the direction that the current flows.
Ah,
Remember how we were talking about electricity flowing from positive to negative?
right, like a one-way street.
Exactly.
Yeah.
So even if everything's connected,
Yeah.
if the setup doesn't let that current flow in that specific direction, the bulb's not going to light up.
Oh, so it's not enough just to have a complete circuit.
I mean,
You have to have the right direction, too.
you got it.
Huh.
So placement of those components matters just as much as having a complete circuit.
That makes sense.
So think about like all the circuits in your house. They're super carefully designed to make sure that electricity is flowing in the right way.
Yeah, to power everything safely and efficiently.
It's like a giant puzzle.
It really is.
And it makes you realize how complex something as simple as turning on a light switch actually is.
It does. And it also goes back to that thing we were talking about before.
What's that?
About respecting the power of electricity.
Right.
Even when we're working with these basic circuits, understanding that direction of current flow, it's key for safety and for making sure things actually work.
I'm with you on that one. Okay, so let's switch gears a little bit.
Right.
What if we replace the wires in our circuit
Okay.
with something like a jute string?
The jute string.
Would the bulb still light up?
What do you think?
Well, I'm guessing no.
You are right.
Okay, good.
It all goes back to conductors and insulators.
Right.
Metal wires, they're excellent conductors. Electricity just flows through them, no problem.
Yeah.
But jute string that's made from natural fibers, it's an insulator, so it blocks that flow of electricity.
Kind of like the rubber or plastic coatings we use on wires.
Exactly. It's all about safety.
So it's not just about having a complete circuit.
Right.
It's about making sure that circuit is made with the right materials.
Yes, because imagine if we used a conductor for the casing of a power outlet.
Oh, that would be bad.
Yeah, that would be really dangerous.
Don't try that at home, folks.
Oh.
All right, so before we move on,
Okay.
we were talking about air as an insulator.
Oh, yeah.
Can you talk about that a little more?
Sure. So air in its normal state
Yeah.
doesn't conduct electricity very well.
So that's why we can have exposed wires in our homes
Right.
and not be constantly getting shocked.
Exactly. That air between the wires and us acts like a barrier,
Okay.
and it stops that flow of current.
Well, wait a minute. If air is an insulator,
Yeah.
how does electricity travel through the air in things like wireless chargers?
Oh, that's a great question.
Or even lightning strikes.
Yeah, that seems kind of contradictory, right?
It does.
So here's the thing.
Okay.
While air is generally a good insulator under the right conditions,
Yeah.
it can actually become a conductor.
What? How does that happen?
So, like, with a lightning strike, the electrical potential difference between the cloud and the ground,
Okay.
it gets so huge
All right.
that it actually ionizes those air molecules.
Oh, wow.
And that creates a pathway for the electricity to flow.
So it's like the air is transformed into a conductor.
For a very short time, yes.
That's wild.
And with wireless chargers, it works a little differently.
Okay.
It uses electromagnetic fields
Oh.
rather than direct current flow. But the main thing to remember
Yeah.
is that even simple ideas like conductors and insulators
Right.
can get really complex depending on what's going on.
So much more to learn.
Always.
All right. So I think we've kept our listeners waiting long enough.
I think so too.
Let's reveal that surprising conductor from the textbook.
Okay, are you ready?
I'm ready. Drum roll, please.
Okay.
The surprising conductor is pencil lead. Who knew?
Or, more accurately, the graphite inside the pencil lead.
Okay.
It's a really cool example of how a regular everyday material can do something unexpected.
Right. We use it for drawing and writing,
Yeah,
but it can also carry electricity.
it can.
Like science is full of surprises.
It is. It's always challenging us to think differently.
That's what I love about it. Welcome back to our final part of this electrifying deep dive.
I know. I can't believe how fast it's gone.
It's flown by.
It
It
has.
really shows how fascinating this topic is.
Yeah, for sure. Even just these basic ideas lead to so many cool questions.
Totally. So before we reveal that surprising conductor,
Yeah.
let's do a quick recap of what we've covered so far.
Okay.
We talked about the electric cell as our power source,
Right.
the light bulb with that glowing filament,
Mm-hmm.
and how important it is to have a complete circuit for that electricity to flow.
And don't forget about conductors and insulators.
Right. Those materials that either help or hinder the flow of electricity.
And we've seen how those concepts show up everywhere.
Yeah.
From the wiring in our houses to how we stay safe around electricity.
Speaking of everyday stuff,
Mm-hmm.
did you ever take apart a flashlight when you were a kid?
Oh, yeah, totally.
It's like I was obsessed with seeing how all those little pieces work together.
There's something so cool about figuring out how things work.
Right. Especially something you use all the time.
Exactly.
And this textbook actually has a diagram of the inside of a flashlight
Oh, neat.
with every single part labeled.
That's awesome.
It's a good reminder of how these simple components can come together to create something so useful.
It really is. And it all comes back to those basic principles of electricity.
Okay, but before we get to the big reveal,
Okay.
there's one more thing from the book that I found really interesting.
All right. What is it?
It says that our bodies can actually conduct electricity.
Oh, wow. That's a little freaky.
Right.
Right.
Like it makes you realize how powerful electricity really is.
It does, because our bodies are mostly water and salts, which means they can create a path for electricity to flow.
So all those warnings about not messing around with electrical sockets,
Yeah.
that's not just about saving the toaster.
Nope.
It's about keeping ourselves safe.
Exactly. And that's why insulators are so important.
Right.
Like, think about electricians. They wear rubber gloves and use tools with insulated handles
Yeah.
to stop the electricity from flowing through them.
Literally lifesavers.
Okay, hard.
So these simple concepts can have huge implications.
It's all about using that knowledge to stay safe.
Okay. I think we've kept everyone waiting long enough.
I think so too.
Time for the big reveal. The surprising conductor is pencil lead.
Ta-da!
I know, right? Who would have thought?
It's amazing how something we use every day can have these hidden properties.
It really makes you think twice about the things around you.
It does, and that's what science is all about.
Challenging our assumptions and making us look at the world in new ways.
Exactly.
Well, that brings us to the end of our deep dive into electricity and circuits.
I hope everyone learned something new.
I did.
Me too.
And if this sparked your curiosity about what other unexpected materials might be conductors,
Yeah.
well, that's the perfect starting point for your own explorations.
Keep that curiosity going.
Until next time, stay charged up.